All right, so we're going to begin P1, P2, P3. Um, if you watched the last video, I'm just going to add one extra thing on here that I forgot to add. Binomial. Again, the expected value is NP. The variance is NPQ. And the standard deviation is NPQ square root. So once again, binomial, nice quick formulas, but that's just it. I just want to mention that briefly. Let's go back to P1. So the focus of P1 is continuous random variables. So continuous random variables. And so instead of thinking about it in terms of like, a table or a histogram, rather we're going to look at it in terms of a integral. Okay. That's kind of the idea as we're looking at it in terms of integration. So any specific value is going to have a probability of what's it called? 0, but as a whole, it does add up something. So let me just find, I guess P1 itself. I guess P1 and P2 kind of have to go hand in hand because P1 is just continuous random variable. Sorry, so let's do this. P1 slash P2. Like they have to go together. So a continuous random variable has infinitely many numbers. And so the focus is, probability distribution functions. So a probability distribution function give me a nice definition of it. Sorry about that. Slash, I'll call it density function as well, is a function that represents a continuous random variable. Kind of vague, I know. So we focused on 3 of them. So I'm going to remind you of the 3, but before I move on, the general definition that we're going to focus on, like this is the main focus, is the probability between 2 numbers. Now, here's a nice thing. Whether you write less than or equal to or not, it actually doesn't matter. But just to be safe, we'll do less than or equal to, is the integral from a to b f of x dx. Okay, like that's the whole core of it. And if we want to find the probability between 2 numbers, it's going to be the probability from a and b of f of x dx. And actually, should I do it this way? No, it's fine. It's fine. And so in order to be a density function, the integral from a to b f of x dx must be equal to 1. Like that's the rule. It has to be equal to 1 if we want to do anything. Any questions? I want to make sure. So we focused on 3 specific ones, and those 3 specific ones were uniform, continuous, and normal distribution. Now, we're not going to go normal distribution. We're not going to focus on the integration part because it's just too complicated. So we're really only going to focus on uniform and continuous. Okay. And I know this is going to be an annoyance in the future, so I apologize, but I'm going to change these to C and D because later I might want to use the letters A and B for something else. Let's just call them C and D. Okay. And so we're going to talk about the 2 main ones, which are uniform distribution and then continuous distribution. I am not going to talk about normal distribution in this context because once again, if we're using normal distribution, we're just using z-score and all that stuff. So there's really no value in doing that. Okay. So the uniform density function, I'm just going to copy and paste this from the textbook. So the uniform density function over the interval AB is given by f of x equals 1 over b minus a. Okay. And so the graph to that is going to be the following. Like I said, I'm just copying and pasting so to save time. It's going to be a rectangle. That's how you know it's a uniform rectangle. And so the height is 1 over b minus a, and then the length is b minus a. So remember, area has to be equal to 1, and the rectangle is, length times width. So area is equal to length times width. So then area is equal to b minus a times w. So then this has to be equal to 1 times b minus a w. So then w is equal to 1 over b minus a. And that's how you get the height. Okay? But you don't have to memorize that. You can just say, so you don't have to remember that. Construction is 1 over b minus a. Now, continuous distribution, or sorry, continuous is the wrong word. I want to say exponential. But the word continuous does apply to it. So an exponential is going to be the following. It's of the form ae to the ax. And that's why I changed my letters so I don't have that conflict again. And the graph of this one is going to be the following. So that's what the graph looks like. For us, it's always going to be decaying. Okay. So you just have to remember those 2 basic distributions. Okay. Are there any questions on that? I want to make sure. And so let's see what I want to do with this. We're going to practice some problems from the homework. So let's first just look at density functions on their own. So let's do something like, how do I want to do this? No, not this one. Let's do number 28. Fine. So find a value of k for which the given density function is a probability density function. So in this problem, I want to know what value of k is going to make it a density function. So it's inside of the formula. The one before it has it in the bound. But in either scenario, the idea is you're going to solve for k. Okay. So remember that the integral from c to d f of x dx has to be equal to 1, right? That is the rule. Now, when you do a problem like this, I'm not going to make you do the most complicated integral, okay? You just need to know the basics. So, like, these are the basic integrals you need to know. The integral of some constant dx is that constant times x plus some constant d. Okay, but you know, we're going to ignore that because we're just going to use definite integral. The integral from x dx is equal to x squared over 2. Now I will write plus c. Sorry, that's like force of habit. And then the integral of e to the x, e to the kx dx is equal to 1 over k e to the kx plus c. Okay, like those are the basic integrals like you have to know. Like if you don't know these, you are going to have issues. Okay, so for this one, so the integral, so this is c and this is d. So the integral from -2 to 2, 8k dx. Okay, now here's the thing you have to remember. K is not a variable. K is a number. It is a constant. So you do not do k squared over 2. It's not k that's the issue. It's not a number. It's a number. Leave it alone. So this is going to be equal to 8k times x, because 8k is like the number 5 to me. And I'm going to go from -2 to +2. So I'm going to replace every x with 2 and then subtract it with 8k times -2, like that. So this is f of c, sorry, wrong letter, f of d minus f of c. And so I get 16k minus -16k, which becomes 16k plus 16k, which is 32k. And what does this have to be equal to be a density function? It has to be equal to 1. Does everyone see that? So 32k is equal to 1, so k is equal to 1 over 32. And that is the number that is going to give you a density function. Are there any questions on that? I just want to make sure.
So why would it be just 8kx and not, for example, 8k squared over 2?
Because this is x, not k. Now, if it was 8k dk, then yeah, it would be 8k squared over 2, but it's dx, so k is a number like 5. It's not the variable you're taking the derivative with respect to, or integral. So the dx tells you what letter is actually changing. That's the letter you have to pay attention to. Does that make sense?
Yeah.
It's just how integrals work. Like, let me give you an example. The integral of x dx, like this letter matches with this letter. So I have to manipulate it. But if I had like alpha x, is alpha the letter x, yes or no? No. So alpha is just a number to me. It's a constant. I leave it alone. So then this would be equal to x squared over 2 times alpha. So the letter k is not the variable I'm integrating. X is, and it's always x for us. Okay? That's just how integrals behave.
So if the f of x was, for example, 8x or 8kx, then we
Then
would
yes, you would manipulate the x part, but the 8k you would still leave it alone.
Okay.
Okay. Any other questions? All right. So that covers that example. So let's just do one uniform. And then let's do one continuous, and then we'll move on to P3, because this is the end of P2. So the grade point average of gourmet society are uniformly distributed. See the word uniformly distributed between 2.5 and 3.5. Find the probability distribution function f of x. So step 1, draw distribution. So it does help to draw these. Okay. So what is the starting amount? 2.5. What is the ending amount? 3.5. And it's going to be uniform, so it's a rectangle. So this is A and this is B. So then step 2 is find f of x. So f of x is equal to 1 over 3.5 minus 2.5, which is equal to 1 divided by 1, which is 1. So that is the f of x value. And that's A. Just making sure that's correct. Yep, 1. Any questions on that? Part B says, okay, find the probability that you're going to choose someone between 3 and 3.2. So the probability that you're going to be between 3 and 3.2, like that. So you're going to integrate from 3 to 3.2 of 1 dx, because that's f of x. So on your calculator, how would you do that if you want to use your calculator? Well, actually, we don't have to do for this one. We'll do for the next one. So what's the integral of 1? That's going to be x. The integral of a constant, specifically number 1, is x. Okay. So cx, c is 1, so 1 times x is x. And then you're going to go from 3 to 3.2. So 3.2 minus 3, and then 0.2, just like that. Okay. Any questions on that? Sometimes I think uniform distribution is like, it's a little too simple. That makes it difficult. Like the simplicity of it is what makes it so challenging. So you have to be careful with that. Okay. Any questions on that? All right.
Do you have time to do 27 real quick?
27. Yeah, we could probably do that after I do this 30.
I have a question on this one. Why
Yeah.
wouldn't we just use 1 minus B, 1 over B minus A, sorry, for B?
Because that doesn't give you the 1 minus B over A is for what's it called? The area, the height of the entire rectangle. So what we found was this part right here. So like 3 to 3.2.
Okay, okay.
Yeah,
Nice.
so this is what we found, 3 to 3.2. So this gives you the height, which is 1, and then that gives you the area, which is 1 total. Okay. The integral of AE to the negative AX, it would be negative 1 E to the negative AX. But you're going to use a calculator. You don't want to use that one. You don't want to do that one by hand. You want to use a calculator because it's just too much work to do by hand because of all the ugly numbers. Okay. Suppose a website is losing membership continuously. So you look for that word continuously at a rate of 5%. Using a suitable density function to calculate the probability that a randomly chosen member will be lost in the next 4 years. Okay. So you see the word continuously. So step 1 is to draw a distribution. So I see the word continuously. That means I'm using this picture right here. Okay. And then step 2 is to find f of x. So f of x, using the word continuously, means a e to the negative ax. And so a is the rate of change, or the growth rate, or the decay rate, I guess, technically. So you're decreasing, you're losing 5%. So it's going to be 0.05, because 5% is 0.05, e to the negative 0.05x. Okay. And so, let me just double check something. It does cross, yes, it does hit the end. And so what I'm doing is I'm going to the 4th year, and I'm finding the area under the curve like that, okay? So then step 3 is to plug in. So the integral from 0 to 4, 0.05 e to the negative 0.05 x dx, like that, okay? And so we use our calculator, clear that. You're gonna do math, click on the math button, and you're gonna go down, and you're gonna go to the option number 9, fn int. I'm going to send an announcement on this, but I'm telling you right now, if you have an Inspire CX2 or a CAS, I need to verify that you can't take integral symbolically. I will let you go into test mode, but our syllabus states that you're not even supposed to have those calculators. So if your calculator is a CAS calculator, like an 89 too, specifically as well, you're not supposed to use it because it can do these integrals symbolically. So please verify you have a calculator you're allowed to use. Okay, so giving you a heads up. So you're gonna press an fn int, and then we're gonna go from 0 to 4. Now, if you're wondering, hey, mine doesn't look like that, it looks like this instead. Maybe you have an old 83. Well, then you're gonna type in the function first, so f of x. Then you're gonna type in the letter x. Then you're gonna type in a and b. So that goes right here. X is just x, and then this is 0, and then this is 4. Okay, so we're gonna type it in. 0.05 second, division symbol, caret symbol, negative 0.05 x dx, okay? And then press enter. And that's your answer. There is an 18% chance or a probability of 0.1813. I remember if that's correct on number 30. Yep. And that's how you do it. Don't do that one by hand because you're just gonna waste time. It's like a lot of numbers you gotta deal with. You said to do number 27, right? Do that one real quick.
Please.
So this just says find a value of k for the f of x function where it's on the interval 0k. So this is c and this is d. So the integral from 0 to k, where k is like a number to us, 5x dx, and this has to be equal to 1 to be a density function. So what's the integral of 5x? 5x squared over 2, and you're going to go from 0 to k. So that means you're going to have 5k squared divided by 2 minus 5 times 0 squared divided by 2. And what does this all have to be equal to? The number 1, because it's a density function. So then you get 5k squared divided by 2. Well, anything times 0 is 0, so that just becomes 0. And this is equal to 1. Does everyone see that? And so if I multiply both sides by 2, I get 5k squared equals 2. And then if I divide both sides by 5, I get k squared equals 2/5. And if I take the square root of both sides, k is equal to, you can just do plus, or you can do the +1 because you don't need the -1. Square root of 2 over 5. And I don't know, did they give me that number in the homework, or did they just say square root of 2? Yeah, that's it. You wouldn't take the -1 because you don't want a negative boundary. It doesn't make sense. Does that answer your question on how to do it? I want to make sure.
Yes, thank you.
All right, that's P2 and P1. Now P3. Does anyone need more time with that slide? I don't know. I might be going too quickly just because it is getting super late. So I'm going to make sure I don't run out of time. All right, so I'm just going to pause for a moment. So P3 is the same thing, really. It's just the expected value, the variance, and standard deviation of density function. Okay. So basically, you can do it two ways. You can either do it using the integral version, or if you remember the shortcuts, you can do the shortcuts for each of them, specifically uniform and continuous, right? So what are those shortcuts and what is the base formula, right? So whichever one you want to use. So for a uniform, we'll do that one first. F of x is equal to 1 over b minus a. That's nice. 1 over b minus a. And then e of x, expected value, is equal to the integral from c to d, 1 over b minus a times x dx. Like, that is the formula for it. Or e of x, the expected value, is equal to, I just got to find the formula because I don't remember it off the top of my head. Or did this one have a shortcut? I feel like it did. I might look in the textbook. Give me 1 second. A plus b over 2. So that's like the shortcut to doing it. You don't have to take the integral. The variance is equal to the integral from c to d, 1 over b minus a times x minus mu squared dx. Like, you would actually have to put that in the integral. Okay. Or the shortcut is, now this shortcut is not easy to remember off the top of your head because it's just kind of a weird one. The variance is equal to b minus a squared divided by 12. Okay. And then the standard deviation is just the square root of the variance. Okay. That's for uniform. For exponential, the expected value is equal to the integral from c to d, a e to the negative ax times x. Yeah. Again, you really don't want to have to do that one because that one's pretty nasty. The integration by parts. Or e of x is equal to 1 over a, like that, 1 over a. The variance, I might run out of room right here, is from c to d, a e to the negative ax times x minus mu squared dx, or e of x is equal to 1 over a squared. Okay. And then the standard deviation is just the square root of the variance, which is actually equal to e of x. Like, turns out they're the same thing. Okay. Now, I just realized that I kind of skipped the base formula, so I'm going to copy and paste this into a new slide. And then I'm going to erase this and give you the base formula without all of that information. Sorry, I just kind of got ahead of myself right there. So the expected value for a density function is the integral from c to d x times f of x dx. Okay. And the variance from c to d of x minus mu squared times f of x dx. It looks exactly the same as the last one. It's just, what's it called? An integral instead of a square root. Sorry, a sum. So we'll do an example from practice.
So are these for uniform or exponential?
So the ones that so these are the general formulas. For any f of x. Like it doesn't matter what f of x is. And then if it's specifically uniform, then you just plug in f of x equals 1 over b minus a. If it's specifically exponential, it's ae to the negative ax. Does that make sense?
Yeah,
So like this is like the general formula that would work with anything. Yeah.
so unless like told otherwise, we'd use these formulas.
Yeah, exactly. Unless you know it's a uniform one, right? All right. And so let us practice an example from the homework. And this one will be where it's not either of the two. That way we can just kind of see what that's like. So consider a density function 3x squared. Find over the interval 0, 1, find the expected value, variance, and standard deviation. So regardless of the problem, you have to find the expected value first. You have to find e of x first. So step 1 is to find e of x. Find e of x. So e of x is equal to the integral from 0 to 1 x times 3x squared dx. Okay. Now, this one you can usually do on your own if it's a simple one. And so this is going to be 0 to 1, x times x squared is x cubed. Okay. And then this is going to be equal to 3x to the 4th power divided by 4. You add 1 and divide by the new exponent. From 0 to 1, and then you're going to plug in 3 times 1 to the 4th. Parentheses do matter, especially when they're negative. Minus 3 times 0 to the 4th power over 4. Well, anything times 0 is 0. 1 to the 4th power is 1, so it's 3/4. That is my expected value. That's E. I have found the first part of the answer, which is also equal to mu. The variance is equal to the integral from 0 to 1. But instead of x, it's going to be x minus mu, and mu is 3/4 squared times 3x squared dx. Like this one, don't even try to do it by hand because it's going to be too complicated. So we're going to practice doing this one in the formula. Okay. So second, sorry, let me clear this. Second, nope, math, sorry, no second, just math. All the way down to option number 9. You're going to do 0. You're going to do 1. And then do a parenthesis. You have to do a parenthesis. And then you're going to do x minus 3 divided by 4. Close that parenthesis. And then square it. And then times, or you can just write it right next to it, times 3x squared. And then you have everything. And then you're going to put a dx, right? So that's what it should look like. Like that. Press enter. And your answer is 0.375. Okay. And then step 3 is to find sigma of x. Well, sigma of x is just the square root of 0.375. Oops, sorry, 0.375. You could. Oh, no. No, you cannot square e of x for the variance. You could square sigma of x for the variance, but not e of x, no. And so that's going to be equal to, what number is this, 37? 0.1936. Okay, so you can't square e of x because e of x is not the square root of the variance. That's sigma of x. So sigma of x is you could square that one. Yeah. Does that make sense? All right. And I'm just looking through the homework practice, and that covers P1, 2, and 3. So we'll stop the video there.